Alright, so looking at the equation of this parabola in standard form, and I don't know much about what it looks like. That's pretty tough to graph as it stands. So what I'm going to try and do is we're going to try and put this into some nice vertex form of a parabola, and if I can transform this graph into something that looks more like that, I think we're going to have a much easier time graphing it. So the first thing I notice is I've got this -2 coefficient on my x squared, and that's really going to mess things up. I know I'm going to have to complete a square eventually, and I don't know how to do that unless my x squared has a coefficient of 1. So I know I'm going to have to deal with this -2 at some point. So what I'm going to do is I'm going to factor it out, but I'm going to factor it out of only these first two terms. And I'm going to leave this 2 on its own. Let it do its own thing for a second. So -2 times the quantity of x squared, and then plus 4x. I'm going to leave this 2 on its own. So here we go. I see 2/3 of a perfect square trinomial. I've got to complete the square. That's what we got to do. Now, we know what we need to do to make that a perfect square trinomial. We need to add a 4. Now, I've still got this plus 2 left over, and now I'm going to say, well, okay, I've obviously done something to this side of the equation. We've got to keep this equation balanced. If I'm going to add something to it or subtract something to it, I've got to make sure that I account for that somehow. So I'm going to say, you know what? I want to know what have I actually done to this side of the equation by putting in this plus 4. And so what I say is, well, what if we actually expanded this this expression right here? And I think we'd end up with, well, y equals -2x squared. Okay, that's the same as what we had in the beginning. We've got our -8x. That's the same as what we had in our beginning. And note, of course, we have our plus 2 per usual. So as it stands, okay, now we got to figure out, well, what did we change by adding this 4? Because right now, this is exactly the same. So what did that 4 change? Well, I think if I multiplied that -2 by 4, I would end up with a -8. So my claim is to balance this equation, I'm going to have to also add 8 to this right-hand side of the equation. So in effect, these two add to 0, and this entire expression is exactly the same as that one. We haven't changed what it is, we've changed what it looked like a little bit. So adding 8 there is exactly what's going to keep this equation balanced. Note, -2 times 4, we've subtracted 8. This is, positive 2 times 4. Just put it on your radars. Alright, so let's get rid of this guy. Alright, well, hey, check it out. We've completed the square. That is awesome. Here is our perfect square trinomial. So we've got y equals -2 times the quantity of x plus 2 squared. And then, of course, we added this 8 to keep the equation balanced. And these add to 10, the y-coordinate of our vertex. So we've got it in vertex form. Everything is groovy. We have our vertex at the coordinates -2, 10. We've got our axis of symmetry, the vertical line x equals -2. And I strongly suggest actually graphing your axis of symmetry. I find it very, very helpful when I'm sketching my parabola. So there it is. Our y-intercept is usually what I do next, and I see it right here. Our standard form of these quadratics are good for almost nothing, but they do tell us our y-intercept very easily. So we got our y-intercept right there at +2. And we've got another point over here, because if I have a point 2 units to the right of the axis of symmetry, I better have one 2 units to the left. And I mean, we already have a pretty accurate idea of what our parabola is going to look like. I mean, this thing is going to be real steep. But let's find a couple more points. I always want to find the x-intercepts. That's just really important stuff. So I'm going to find these. I'll do that one in maroon here. So I'm just going to set y equal to 0 in this vertex form of the parabola to solve for the x-coordinates. That will be our intercepts. Alright, so we've got our equation all set up. Let's do it. So if I subtract 2, we got -10 equals -2 times x plus 2 quantity squared. I'm going to multiply both sides of this equation by -1. So I'm going to divide both sides by 2 now. 5 equals x plus 2 quantity squared. Alright, let's take the square root of both sides. So we got plus or minus the square root of 5 equals x plus 2. Almost there. Subtract 2. So x equals negative 2 plus root 5 and negative 2 minus the square root of 5. Alright, well, now I'm thinking the square root of 5. Well, what's that around? Well, 5 is between 4 and 9. It's a little bit more than 4, so I'm going to say it's a little more than 2. The square root of 5, that is. A little more than 2. So our intercepts are going to be a little bit more than 2 away from our axis of symmetry to the right and the left. So let's go ahead and graph these guys. So here's our axis of symmetry. We're going to go 1, 2, and a little bit more to the right. Alright, there's our 1x intercept, and we'll go 1, 2, and a little bit more to the left. There's another one. And so, not surprisingly, I mean, those really make sense for where we thought they would be, considering these other points that we had already found. And we're pretty much ready to go ahead and sketch our parabola. If you want to find another point, maybe I'll try x equals positive, maybe x equals negative 1 might be really helpful for finding another point. So if x equals negative 1, then y would be, well, negative 2 times negative 1 plus 2 quantity squared plus 10. So negative 2 times 1 squared plus 10. Negative 2 plus 10, so 8. So we've got the ordered pair, negative 1, comma 8. And that's going to help us get a super duper accurate graph. And what's also nice is we've got this other one on the other side of our axis of symmetry, and we are ready to go ahead and sketch. From there, I could do that a little better. There is a sketch of our parabola.